Okay, let's now solve the problem appeared in problem 4 in the IMO 2013. So it's how can I rate this question? It is a little bit hard to think, but it is not that difficult. So if you can find the way to prove and after that the solution comes. So let's just discover the hints inside the problem. Let ABC be an acute triangle with orthocenter H, and let W be a point on the side BC between B and C. Points M and N are the feet of the altitudes drawn from B and C, respectively. Omega 1 is the circumcircle of triangle BW, and is this one. And this is omega 2. And Y is a point on WY. No, X is a point such that WX is the diameter of omega 1. So, since WX is the diameter, then we can know here the angle XVW equals to 90 degrees. Similarly, here it is also the same, right? So, how can we continue doing that? We want to show that the points X, Y, and H are collinear. It is not easy to prove directly, but we can use some other points. For example, this point. For example, this point. If I call it the point P. You might think, if will the two circles and X, Y meet at one point, which is P? The answer is yes. So how can we prove that? For example, if omega 1 and xy meet at P not different to X, then we will have the angle XPW equals to 180 degrees minus the angle XBW equals to 90 degrees, right? And since here as we have assumed XPY are collinear, then so we have angle WPY equals to 90 degrees because it is 180 degrees minus 90 degrees and equals to angle WCY. And then we can know that WPYCR concycle. And it means that P is on omega 2. Then we know omega 1, omega 2, and XY meet at together at P. So P is actually on the line XY. So what we want to prove is to prove that X, P, H, and Y lie on one line. So the problem comes, how can we deal with this? Okay, pay attention that we have another hint. If you have watched my previous videos, you might think of one thing that proves like some points are collinear. The method is to use the radical axis. Now it can be used in proving A, P, and W collinear. Let's do it. Like, let me write. We try to prove A, P, and W are collinear. If we connect the points, how about the ruler? So we know that PW is the radical axis of omega 1 and omega 2. Then we try to prove that A is also on the radical axis. That means the power of A to omega 1 equals to the power of A to omega 2. Is that true? The power of A to point A to omega 1 equals to AN times AB. And let me write it here. The power of A to omega 2 equals to AM times AC. Actually, they are the same. Why do I say it is because angle BNC equals to angle BMC. It shows that B, C, and N are consecutive. And then we have AN times AB equals to AM times AC. So A is also on the radical axis of omega 1 and omega 2. Is that right? Then after that, we know that A, P, and W are collinear. So we have proved that the first part of the question. And let me copy this photo. And I will write it in the next page. Let me do some little changes. Maybe here, and we try to connect the points A and H. As you can see, they are here. Oh, I have to say one thing before. We have A, P, W collinear. Then we know that AP times AW equals to AM times AC, which is equivalent to the angle APM equals to, no, it is similar to triangle ACW. So if we connect the points P and M, we will find that the angle ACB equals to the angle APM. The magical thing will come if we extend AH, and that is intersect BC at maybe Q. And here is the point Q. We know that AQ angle AQC equals to 90 degrees equals to angle AMB, and that leads to H, Q, C, and M are coinciding. And after that, the angles AHM equals to angle ACB, right? So we can mark it here and here. As we see, the angles in purple are all the same. So what can we get? So we have angle APM equals to angle AHM, and that leads to APH and M are coinciding, right? So after that, what can we have? We can know that angle APH equals to angle HMC equals to 90 degrees. Plus, we know that angle APY equals to 90 degrees. Oh no. Angle APY equals to angle WCY equals to 90 degrees. Is plus here. So angle APH equals to angle APY. What does that mean? That means PHY are collinear. Since X is on the line HY, oh no, PY, then X, P, H, and Y are collinear. i.e. X, H, Y are collinear. So that's the end of the proof. So after seeing the whole question, how do you like, or what do you think of this question? It is not that difficult at all, right? But one thing you might have to, the two things you have to discover is that one is the point P, and then after discovering the point P, you have to find that AP and W are collinear. So these are the two things that are a little bit hard to find out. And okay, that's the end of this question. So thank you for watching.